Welcome to Cosmic Compass, the channel where we explore the mysteries of the universe one story at a time. From the birth of stars to the fate of entire planets together, we unravel the science and the wonder of the cosmos. Today, let's set our sights on a world that has captured human imagination for centuries, Mars. Is it humanity's next great home, or will it remain forever out of reach? Let's dive in and find out. Ever since humanity looked up at the night sky and recognized Mars as a world with uncanny similarities to our own imagination has run wild. For generations, people have wondered not only whether life once existed there, but also whether our lives could take root on the red planet. But can we as a species truly colonize Mars? And if so, how would we actually do it? Today, let's journey together into this question. We'll weigh the opportunities, the dangers, and the extraordinary challenges that stand between us and a permanent home on our neighbouring world. The fascination with Mars is not new. In the late 19th century, astronomers believed they saw canals etched across the planet's surface structures they thought were carved by intelligent Martians. By 1911, even the New York Times ran stories entertaining the idea of a Martian civilization. Looking back, it wasn't such a wild assumption given the limits of telescopes at the time. Fast forward to modern science, robotic pioneers like Viking in the 1970s followed, decades later by opportunity, curiosity, and now perseverance have fueled global interest in Mars again. These missions sought answers to profound questions. Did Mars once host liquid oceans? And could microbial life have thrived there? Today, entire organizations exist with the sole mission of promoting Martian colonization, from the Mars Society to private ventures like Mars One. Humanity's dream of reaching Mars has shifted from science fiction into engineering proposals and policy discussions. But dreaming is only the first step. Let's start with the trip itself. Under optimal launch conditions, traveling to Mars would take about 3 months. That doesn't sound too terrible. It's like a long voyage at sea. But imagine spending 3 months outside Earth's protective magnetic shield. Out there, cosmic radiation and the solar winds stream towards you with little to block them. Prolonged exposure increases the risk of cancer, and some scientists warn it could even accelerate neurological diseases like Alzheimer's. To counteract this, researchers have proposed spacecraft walls lined with hydrogen-rich materials, perhaps even tanks of water surrounding crew cabins. Another idea is generating an artificial magnetic field, though the power requirements for such a reactor are beyond our safe capabilities right now. And then there's communication. On Earth, a phone call to the other side of the world carries only a tiny delay, but on Mars, signals take between 3 and 22 minutes one way. That means a conversation could stretch into half an hour just to exchange a single sentence. In emergencies, settlers won't be able to call for real-time help. They'll need to rely on themselves. Assuming we survive the journey, where would humanity's first outpost go? Mars offers no single obvious choice. The polar caps are rich in ice, making them tempting. The Korolev crater, 81 kilometers wide and filled with frozen water, is another candidate. We also know of underground reservoirs, pockets of water locked in permafrost beneath the crust scattered across the planet. Tapping these could allow settlements at lower latitudes where sunlight is stronger for solar power and temperatures less extreme. And then there are lava tubes, long tunnels carved by ancient magma flows. On Earth they form caves. On Mars, they may be large enough to shelter entire habitats, offering natural protection from radiation and meteorites. Settlers will likely seek a site that combines these advantages: thicker atmosphere for landing access to water, and perhaps the safety of underground caverns. Of course, finding the right spot is only the beginning. Colonists cannot simply arrive and set up camp. Multiple precursor missions would need to land first, bringing robotic builders to prepare the ground. Many concepts rely on 3D printing habitats from local materials. Imagine autonomous machines excavating regolith, mixing it with ice, and layering it like concrete into dome-shaped structures. Once built, these shelters would be buried under more regolith for radiation protection. Other proposals include inflatable modules coated with ice, or even biological designs inspired by fungi. What unites these visions is the need for machines to do the heavy lifting before humans arrive. Astronauts in bulky suits can't dig trenches or operate machinery all day, so robotics and artificial intelligence will be the unsung heroes of Mars colonization. Let's assume the first habitats are complete. What then? Settlers will arrive to a harsh environment where survival depends on three things: air power and water. Air can be generated through electrolysis, splitting water into oxygen and hydrogen. The oxygen provides breathable air, while hydrogen can be refined into fuel. Recycling systems like those on the International Space Station will also be vital. The Perseverance rover is already testing MOXIE, a small experiment that extracts oxygen directly from Martian carbon dioxide, a glimpse of the future. Energy poses another hurdle. Solar panels will only produce about 40% of what they would on Earth, thanks to Mars's distance from the Sun. Dust storms can also reduce output dramatically. That's why many researchers propose shipping small nuclear reactors. A hybrid system, solar, when possible, nuclear for stability, combined with powerful batteries, seems the most realistic option. Water may be the least of our worries. We know where to find it in polar ice subsurface deposits and perhaps frozen craters. With heating and filtration, settlers could secure several litres per person per day. Recycling systems will minimise waste, just as they do aboard the ISS. With air power and water secured, attention turns to food. Mars offers soil regolith, but it comes with a problem: perchlorates toxic chemicals harmful to humans. To make the soil usable, it must first be washed with water treated with fertilisers and enriched with organic matter. Only then could it support crops. Alternatively, aquaponics presents a clever closed-loop system. Imagine tanks of tilapia, their waste nourishing hydroponic plants. In return, the plants filter and oxygenate the water. Tilapia are hardy, easy to raise, and edible, providing both protein and fertiliser. Waste from humans and the colony itself could also be recycled into nutrients. In reality, a hybrid system, part regolith-based farming, part aquaponics, may prove the most resilient. Still, these farms would demand constant attention and vast amounts of energy, especially for artificial lighting. Life on Mars would be anything but idle. Even if all the technology worked flawlessly, one challenge remains us. Life on Mars would be psychologically and physically grueling. Imagine being confined to a small habitat with the same people, the same tasks, and the same limited diet, month after month. Even in Earth's most isolated environments, Antarctic bases, submarines, people know they can eventually return home. Martian settlers would not. They would be, for all intents and purposes, trapped. Low gravity poses further risks. Experiments on the International Space Station have shown how quickly astronauts lose bone density, muscle mass, and even suffer vision problems. Mars has only a third of Earth's gravity, and no one knows how human bodies will adapt long term. Exercise regimens will be mandatory, lengthening work days and adding strain. Some proposals even suggest genetic modification to better equip humans for radiation or microgravity. While controversial, it reveals the extreme scientists are considering. Colonization will demand not only advanced engineering but also extraordinary human resilience. So where does this leave us on paper? We already possess many of the tools needed for Martian colonization: rockets, robotic explorers, life support technologies. Yet critical gaps remain: radiation shielding, reliable energy sources, and the psychological toll of life in confinement. Still, enthusiasm persists. Every time agencies or private companies announce an application for Mars missions, thousands volunteer. NASA aims for the late 2030s, though timelines may shift. But whether it happens in 15 years or 50, the first colony on Mars feels less like fantasy and more like an inevitability of human ambition. Would you go if given the chance? Could you imagine waking up on a planet where Earth is just a faint star in the sky? In the end, Mars is more than just a planet. It's a mirror reflecting humanity's endless drive to explore, survive, and imagine. Colonizing it will be brutally hard, fraught with risk, and perhaps even morally complex. But the question isn't only, can we? It's also, will we dare? Thank you for exploring this journey with us. If you enjoyed this video, consider sharing it with someone curious about humanity's future among the stars. And let's keep looking upward because the cosmos is waiting.